Hello there, Nareg is here. Today I'm going to talk about vectors. We're going to define what a vector is, plus we're going to talk about the translation of a vector. How are we supposed to do the translation of a certain vector? Let's start with the definition. So in order to find a vector, actually it is a mathematical object which is characterized by three things. The first one is direction. The second one is a sense or an orientation, and the third one is the magnitude or the norm, the value, so a certain magnitude. Now, how do we represent a vector? It's a segment which is, of course, since we said it's oriented, it has a certain orientation. So this will be our segment AB. And since it has a certain orientation or direction, I can simply say that this is the vector AB, which has an arrow at the point B. It could be the arrow at the point A. What does it mean? It means that the initial point is A and the terminal point is B. So since we're defining the vector, since A is the initial point, as for B it's the terminal point. So this is how do you represent your vector. Now how do we write about the vector? You simply say it's the vector AB with an arrow above it. All right. Some other courses or other videos will define vectors by simply two things: magnitude and direction. In this case, I'm taking also the third point, which in this case the second point, the sense or orientation. Orientation, it means from A to B, and direct, which is quite different than a direction. I will take a few examples of where I'm going to discuss about the different positions of two vectors, and we're going to also mention about the direction and sense. Since it has a magnitude, this vector, we can write AB between these two lines, and it means that AB in magnitude, what is the value of this segment of this vector AB? The norm or the magnitude of the vector AB. So you need to point to write it down in this way. Now let's take the different positions that I can have between two vectors. The first one, the most general one, I would like to add also about vectors. In order to understand the concept of vector, you simply have to say that a vector is linked with a certain displacement. You're going from point A to B, from B to C. It's simply a displacement. So in this case, about the positions of two vectors, I'm going to take the first one. This is the vector AB. And this is my vector CD. Now these two vectors have different direction. Why? Because they are both on two different lines. Example, this is the line on which AB lies, and this is the line on which DC lies. So different direction. They have different sense or different orientation. AB is from A to B and it's going towards up. As for CD, it's going towards down, and of course different magnitude. This is the first case. Now the second case, what if I had something like this? This is my vector AB, and this is my vector CD. Now as you can see, they both have the same direction, They are both parallel. Whenever they are parallel, so AB lies on this line, let's say, and CD lies on a line which is parallel. So I can say that they have same direction, they have different orientation, they are not opposite. In order to have opposite, we're going to talk about it, we should have the same magnitude. And in this case, it's also different magnitude. Now, what about, so these two have the same direction, which means they are parallel, or simply they call it collinear. A third case, whenever you have, let's say, AB and CD, as you can see, they have the same direction, they have same sense, but different magnitude. All right. The fourth case, it will be AB and your vector CD. In this case, we have opposite vectors. Why? They have same direction, different sense or different orientation, they are opposite, and same magnitude. So I can write a certain relation between AB and DC. I can say that AB is the same thing as DC, or AB is equal to minus CD. Since it's minus CD, it means that these are opposite vectors. So in this case, I will write it down as two opposite vectors. Their sum should give me 0. So AB plus DC is equal to AB plus CD. In this case, it should be plus CD is equal to 0. So same direction, different sense or different orientation, and same magnitude. In the previous case, for example, we didn't have the same magnitude, or even this one. They have different orientation, different magnitude. That's why I cannot talk about opposite or equal. Now the last case is to have equal vectors. In order to have equal vectors, this is AB and this is CD. All right. These two vectors have the same direction. They have the same orientation or the same sense and same magnitude. So since they have same direction, same sense, same magnitude, I can write down that AB is actually equal to CD. These two vectors are equal vectors. So what about equal vectors? Whenever I have equal vectors, I can say that the quadrilateral, which is ABDC, will be, so ABDC will be a parallelogram. So in this case, ABDC will be a parallelogram. Even in the case where I had opposite vectors, if I will talk about the quadrilateral ABCD, I will be saying that ABCD is actually a parallelogram again. Opposite, it means same direction, same magnitude, simply the orientation is different. So since you have same direction and same magnitude, it means that you have two sides which are parallel and equal, so you will have a parallelogram. All right, so these were the different positions between two vectors. Now what about the vector 0? The vector 0 is actually defined as 0 vector. It has a certain magnitude which is 0. Let's say I have the vector AA. The vector AA is the same thing as the vector 0. How is it represented? It is represented simply by a point. So a point is actually the vector 0 or vector null. The direction and the sense of vector 0 are not defined. Now let's talk about translation of vectors. How do we do translation of vectors? It's very simple. This is my vector AB, and let's say I have another point C. At point C, I will do the same thing as the vector AB. So whenever I'm doing a translation, I'm sliding AB without changing direction, orientation, or magnitude in order to reach the point C. And from point C, I will do the same thing as AB. So from point C, I will do the same thing as AB, and I'm gonna call it CD. So CD will be automatically equal to AB just because I did a translation. So translation of vectors, it's also important just in case you need to move your vector, of course, without changing direction or sense or even the magnitude. All right. Well, that's it. That's it for the definition of vector plus the translation, and of course the position between two vectors. I hope it was helpful, and why don't you subscribe to my channel? You'll be notified whenever I upload new videos. I can also share with you my Instagram and Facebook account. You can contact me directly, or simply you can leave a comment below. So that's it for today. Hope to see you next time.